let's begin. Exciting conversation. I'll start off with just why we do these calls, these Twitter spaces at Celestia. And it roots in a core belief of ours, which is modularism, not maximalism. Mustafa took the stage at the Modular Summit and outlined this pretty well. But in short, these L1 wars have held us back, and there's been this monolithic L1 loop these past 10 years with this zero sum mindset that's just frankly toxic. With modularism, we're more about a positive sum mindset, and we're actively thinking about the next generation of blockchains. And the requisite for success there is to loop in all the stakeholders in the ecosystem to figure out how we want to blueprint this. And so, what we like to do is just reach out to other folks, and Aztec in particular here, to really help us envision what the next 5, 10 years are going to be like. And our vision is around sovereign communities. And part of that North Star is privacy. And who else to ask about privacy and help us think about the intersection of privacy and modularity than Aztec? Um, and so, what we want to do is really go deep into this intersection of privacy meets modularity. And we'll begin with the Aztec side and ask like an open question here. Tell us about how you guys think about privacy, especially anonymity and confidentiality. Explain those for us, and then we'll go into where you see those two variables changing in the next 5 years, given the modular stack.
Yeah, happy to. So when it comes to privacy on chain, you're right. It's a bit of a nebulous concept. So what do we really mean by that? We like to think of it as there are you can get. Well, first of all, just to clarify, when we mean privacy, we mean like observers cannot spy on you and kind of like reconstruct your transactions or what you've been doing on chain. So a lot of like the very night there's an impression that things like Bitcoin or Ethereum are anonymous because your identity is an address and not a name. But that's not really the case. I mean, the more economic activity that you move on chain, the more information about who you are and what you're doing you're starting to reveal. And so, in a world in 5-10 years time when this technology matures and blockchain kind of really fulfills its original thesis of being used as a global settlements layer, as a global transactions layer, people are going to be okay with that if that means that, for example, all of their online purchases are visible to the entire world, if their salaries are being streamed through a public ledger that people can observe and see, things like that. And so just as to clarify, when we mean privacy, we mean cryptographic ironclad privacy, where all of the data going across the network is encrypted, and only you as a user, as an individual, possess the decryption keys for your own data. But within that wider context, there are three forms of privacy. There's user privacy, data privacy, and code privacy. User privacy is when the identity of the individual performing a transaction is hidden. So, for example, if you saw that 15 DAI was sent to an address on chain, but you didn't know the identities of the sender or recipient, that would be user privacy. Data privacy is when it's not just the identities of the transaction are hidden, but also the data being transferred. So going back to that basic transfer, if that 15 DAI was encrypted, so all you saw was that there was a cryptocurrency transfer from two encrypted addresses, and the value was encrypted. And then finally, you have code privacy, where the actual transaction logic being executed is not known by any observer. So if I'm talking to, for example, like the MakerDAO smart contract on Ethereum, then nobody knows that. All they see is that there was a transaction that occurred on Ethereum. It called a smart contract address. Some value may or may not have been transferred, and the identities are hidden. And so once you achieve code privacy as well as user privacy and data privacy, that's when you have kind of a full confidentiality of your transaction. And that's what we're aiming for at Aztec.
I want to go into privacy in monolithic chains versus privacy in modular chains. I'll kick the ball over to the Celestia guys. how do you, Mustafa, let's start with you. How do you see privacy changing given the modular stack?
Well, the way I see it is, I think like so. First of all, pri it seems to me that privacy is inherently more expensive in the monolithic chain because a lot of privacy constructions use cryptography that would have high gas costs if you're deploying it on a chain that does not have like native opcodes, for example, for the operations you're trying to do. So like having a modular architecture where you separate the consensus from the execution using rollups, for example, allows you to do kind of computationally expensive things on the execution layer um, without it being as expensive as if you were doing it on a monolithic L1 where you're sharing the same execution layer with certain limitations as everyone else.
I can add to that because yeah, you've hit the nail on the head, and like Aztec's journey as a company largely reflects that because originally, when we got started, we weren't a rollup, we weren't a layer two. What we had a cryptography protocol that enabled shielded transactions to occur, where everything was verified inside a smart contract on Ethereum. So we were using the Ethereum as both a consensus and an execution layer. But because the EVM and the is not really designed to be optimized around advanced cryptography, it meant that our transactions were extremely expensive because we were sharing this general purpose execution layer with the entire Ethereum ecosystem, and so it meant that transactions like shielded transactions going through that system cost like tens of dollars. Nowadays, with modern gas prices, it would be hundreds of dollars, and so we had to deliberately separate out our execution layer from that of the wider Ethereum network by creating a layer 2 rollup, just in order to enable us to achieve to enable cost-effective privacy on Ethereum. And so a lot of the difficulties that we've been having with that is basically having to build out a lot of the infrastructure from scratch. And so this is why we're really excited about Celestia and separating out the data availability layer from the consensus layer and the execution layer, because that means it makes creating these modular architectures so much more easier to actually pull off without having to invent a ton of tech from scratch.
We'll kick the ball over to John. John, going deeper into the technical aspects of it, maybe a question for you is what aspects of privacy does a rollup enable that a layer one cannot? And more broadly, what are just some of your high level opinions as to where the puck is going?
Yeah, so I guess, sorry, there's some feedback here. Maybe we can mute Mustafa.
Okay.
There we go. Sorry about that. So I guess before diving into what it enables specifically, I think that it's interesting to draw some parallels here between what Mustafa brought up around, there being more resources, and therefore you can do there's the potential to do new things, and kind of the rise of machine learning. Because for a long time, there's a lot of the techniques that are known in machine learning are really just math, statistics stuff that have been known for quite a long time, but they were just computationally infeasible to do. So people were looking for better techniques and so on, and then at a certain point, GPUs just got so damn powerful that you could just literally just brute force training your machine learning models, and it happens to work pretty good. Just off of brute forcing it, off of having access to more compute. So I think we can see something along those lines. Something parallel to those lines could happen because modular blockchains enable so much more data throughput and so much more compute through optimized execution layers. That simply having access to more resources could enable things that, while technically possible, were cost prohibitive before. The exact extent of those things, I'm sure that the Aztec guys are much more familiar. But now, with respect to what rollups specifically enable that you can't get out of a monolithic layer one, I think one thing that's interesting is peer-to-peer privacy techniques. If you're familiar with Bitcoin, there's a lot of concern around the privacy of light nodes and how they interact with full nodes and light client servers and so on. And there's various techniques to anonymize or increase the privacy of transactions at the peer-to-peer layer. So this means like not even like the effects of the transaction, but the actual blob that you send to the peer-to-peer network, privacy on that. So Dandelion++ is one example. Right? It uses some interesting techniques to essentially obfuscate who the sender, like who actually sent out a blob to the peer-to-peer network. And I think that these kinds of things are potentially not necessarily more doable in a stack where you separate different layers that receive transactions, but there's opportunities here for doing something different. Because if you have your data layer and then an execution layer on top, users won't actually be interacting with the data layer, they'll be interacting with the execution layer. And then you can do various things like have more client-server models instead of a peer-to-peer network for various use cases, like Happy Path, for instance. In Ethereum, Flashbots is used quite heavily, and they're essentially assuming you trust Flashbots to anonymize your traffic. They anonymize your traffic to anyone else that isn't Flashbots. So there's more opportunities here through this separation because users don't have to interact with everyone. They have to interact with a subset of that.
Thanks, John. John, too, over to you. Why modular? What intrigues you as you look across the aisle here and see modularity coming from the privacy point of view?
Yeah, I think we like to say that modularity allows us to focus on what we're best at. It plays to our strengths. And what we're best at is private execution. So I think when we think about, why do we, there's a big question, why build a rollup? Why not build an L1? Or why, potentially work with Celestia? And I think we're getting to a blockchain paradigm where everyone is becoming increasingly specialized. And so what we're good at is ironclad privacy, ironclad private execution. And to add to what was said before, we have a product coming out now called Aztec Connect that allows us to combine the best of public execution on Ethereum and private execution on Aztec. And we're big believers that, the public and private domains have to play together seamlessly. If you think about these kind of like human coordination games that we play, privacy is just one of the features. So, there are perfect information games like chess and checkers and backgammon. There are plenty of games that we play that require privacy. And so one of the big reasons to build on top of Ethereum is to build on an ecosystem that is already the leader in public execution and to rely on them for security rather than completely rebuild our security model from the ground up. And so I think really what it allows us to do is focus on what we're good at and rely on, the settlement expertise and security expertise of Ethereum and, the data availability expertise of Celestia. And, I think a lot of the conversation right now is about the capital inefficiency of rebuilding everything repeatedly. And that's kind of what the L1 wars are referring to, right? We're rebuilding everything from scratch continuously. And, what is the marginal difference? It's some kind of like marginal consensus improvement. And, our philosophy is rather than try to innovate on that level, we're going to innovate where we're most specialized.
There's this narrative that rollups are parasitic to Ethereum. True or false? Zach, we'll go to you first on that.
So it very much depends on the architecture. So for some projects, so one of the reasons why people claim that rollups are parasitic to Ethereum is because the costs of moving into and out of a rollup are generally very expensive, which means that there is an enormous amount of pressure to recreate the Ethereum ecosystem of smart contracts within a rollup. So that if you have a layer 2 rollup, that you wanted to have a version of Uniswap running on your rollup or version of MakerDAO and all of the mainstream contracts that are running on Ethereum, you end up cloning them, porting to your rollup, and then the effect of that is basically you've created your another liquidity mode. You've split the liquidity of Ethereum, the user base of Ethereum, between your rollup and the people using Ethereum directly. And that there is logic. I think it is valid to say that has a parasitic effect, because it means that you're taking what was one community and you're kind of splitting it up. Our rollup is not parasitic to Ethereum because we're taking a very different approach, where what we focus on is privacy. So we're not trying to recreate the Ethereum ecosystem but cheaper on an L2. We're trying to give people control over their assets without revealing their identities. And what I mean by that is that you deposit funds into Aztec L2, and in doing so, you shield your tokens, because every user who deposits into Aztec acquires privacy by default because of the way we've architected our ZK rollup. And then if you want to, you can use our effectively our Aztec Connect bridge to interact with layer 1 contract directly on Ethereum, as if you were a layer 1 user. And we do that via transaction aggregation. We use zero-knowledge cryptography and zero-knowledge snarks to basically make a batch of users look like one user. So if 10 people are doing an ETH to DAI trade on Uniswap through Aztec, Aztec basically, the Aztec rollup will send an instruction to Uniswap representing that batch of 10 people. And the costs of that transaction get amortized across all of the users in the batch, and also the identities of all the participants is encrypted. And generally that concept, I think it's called like DeFi pooling, and I think it's going to become very popular in the future, because I think one of the effects we're going to get from these L2 wars is a lot of fatigue, effectively, where the L2s that require ecosystem migrations are going to see very little genuine organic use. Once you remove liquidity mining incentives and that you'll have users from that side of things, but people actually using your network in order to engage, in order to perform some kind of actual economic activity, that's not going to be very common, I think, because people aren't going to be willing to split liquidity. And my suspicion is that the paradigm moving forward for L2s will be to largely use transaction pooling, whilst ensuring that the actual DeFi protocols remain on L1, and therefore we preserve a single liquidity pool.
Mustafa, over to you. Same question.
This is a really
please go ahead.
Yeah, I mean, it's a really interesting question. I think it's a very kind of socio-economic question more than a technical question. I mean, there's three possibilities, right? Either A, rollups are parasitic to Ethereum, or B, Ethereum is actually parasitic to rollups because rollups have to pay rent to Ethereum when they could just be their own L1. Or C, it's a symbiotic relationship and there is no parasitism. The truth probably lies in the third one to some extent, because obviously that's where the balance lies. It's a symbiotic relationship. But interestingly, there's recently been a more of an extremist part of the Ethereum community, which is, well, maybe not extremist, but I mean, there's a part of the Ethereum community that advocates for something called enshrined rollups, which is this idea of it's basically execution shards, right? Where in the future there's this idea, well, we might have a single a rollup that's enshrined to the Ethereum governance, in the sense the Ethereum validators are also the sequences for this rollup. And so I do kind of worry where I don't think this is the view of most people in Ethereum, but I do kind of worry where there's an extremist part that sees rollups are friendly to rollups now, but because rollups are using are kind of diverging from Ethereum in the sense they have their own tokens that aren't using ETH, they're kind of only friendly to them now because they help to scale Ethereum. But then after they will kind of push more to enshrined rollups, because that's kind of more fundamentalist to the Ethereum kind of token or narrative.
John, number one, we'll let you jump in first.
Thanks. I was about to ask. So I have some thoughts here. I mean, it can go either way. And I think that it's important to kind of characterize. Well, first of all, parasitic is a very strong word, right? But parasites usually don't give back at all to their hosts. But there could be the case where, just because a rollup might siphon value off of the base layer doesn't necessarily mean that it doesn't also give back value, potentially equal or more. So there's a bit of a nuance here. Parasitic is a bit of a strong word, but with respect to whether or not a rollup siphons value off of the base layer, I think it's important to distinguish between a base layer that has overlapping responsibilities or features with a rollup and one that does not. For instance, if you use Celestia as a data layer, Celestia does not allow you to do any execution at its base layer. So if you have an execution layer on top of that, then they have completely non-overlapping features or resources that they provide to users. Because of that, it is literally impossible for an execution layer to siphon value off of a pure data layer like Celestia. And in such a case, it would be purely a positive sum game. Whether or not now a rollup will siphon value off of a base layer that also has execution, that's a little bit more tricky because they both provide execution. I do agree with Mustafa though that it is much more. It's, in my opinion at least, it's more along the third option where it's a positive sum game and they reinforce each other. So even though the rollup may siphon off some users off of the layer one, it also contributes back, and it can contribute back more than it siphons off.
Aztec guys, do you guys disagree with Mustafa and John on that third point?
I think I just have a slightly different, or maybe quite frankly, dumber framework to think about it, which is, what do we mean by a parasitism, right? Do we literally just mean the amount of demand for Ethereum resources and block space is going to go down with rollups? And if we frame the question that way, I have a very hard time believing that that's the case. In fact, I'm almost scared of the opposite, that rollups make layer one Ethereum nearly unusable for the typical retail user. And if you think about kind of like the price elasticity within crypto right now, right, there's, I think, an argument to be made that it's hyperelastic. If you cut costs dramatically, throughput goes up by more than the proportion that you've cut costs or pricing to users. And so if I think about rollups getting to sub-penny transactions and being able to support massive throughput, the demand could be far greater than the reduction in cost. And what that means is there should be a net increase in demand for Ethereum block space. And I know John Adler's a really big fan of thinking about resource pricing. I think potentially that allows Ethereum to price resources more effectively, to focus kind of their resource pricing on what they do best in service to rollups as part of this scaling roadmap. And so to make this even dumber and more like, third grade, I personally think when I describe this to the layperson of Ethereum as kind of like a highway, and of rollups as kind of like buses, right? They're able to cram like way more transactions, way more people traveling on the same highway into one vehicle, so to speak. And so now the question is, we have a highway full of individual passenger vehicles, and tomorrow we've introduced a bunch of bus operators. Does traffic on the highway go up or down? My intuition here is that the traffic on the highway goes up, that more people are going to be willing to pay way more, because for each individual bus rider, the cost is amortized over a large number of transactions, and it doesn't do anything, in my opinion, to affect the type of person who wants to take private transportation. If you're the type of person who wants the direct security and privacy, not literal privacy, but the direct kind of like relationship with Ethereum that you do from having a private vehicle, aka interacting with layer one directly, then you'll do that. This doesn't detract from that demand. It's purely incremental. And that's kind of my 101 third grader way of thinking about it.
Zach, would you like to jump in here?
Yeah, I guess it's interesting, right? Because I think the difference here is that I think like so John Woo and Mustafa are kind of, in my opinion, looking at the same ecosystem but in different times. Because right now, rollups are there is a public debate around the rollups being in tension with the base layer, the base execution layer, right? Ethereum does execution, rollups do execution, and so is it parasitic for rollups to siphon value out of Ethereum? Is the utility they add worth in excess of it? There's that conflict. But long term, the fact that Ethereum provides execution is going to become irrelevant, because what people because the thing about the Ethereum's execution layer is it is very, very opinionated and restricted, because it has to be, because it's a monolithic L1. It can execute code, but not very fast. As in, it can't like the number of CPU cycles you can execute in a block of transactions is quite limited, in order to maintain consensus. And so rollups can do execution so much better than Ethereum in the long term, especially when you use zero knowledge proofs, so that in theory you could have you just post the results of like 1 million EVM Ethereum style transactions on Ethereum, and then you just provide the succinct proof of knowledge that the transactions are correct, and and Ethereum has to do basically no execution other than verifying the correctness of zero knowledge proofs. And Ethereum's base execution just can't compete with that long term. And so I guess my long term view is that this debate isn't going to have a conclusion, because it's going to get eaten by this problem is going to get eaten by a larger problem or a larger issue, which is that Ethereum as execution layer will be uncompetitive with rollups long term.
Before I move on to the next topic, I'll let Mustafa give his closing thoughts on this one before we move on.
I don't really have any further thoughts. As I said, I laid out the three possible conclusions. Either rollups are parasitic to Ethereum, or Ethereum is parasitic to rollups, or the symbiotic relationship. And I think the truth usually lies in the middle, which is the third option.
So John, when we had the notes going back and forth, there was this question, I think I've seen it on Twitter too: is modularity a risk to Ethereum? And it's a fair question. And I want to get the Aztec side here for this point of view. So Zach, maybe we'll go with you first. Do you think modularity is a risk to Ethereum?
No, I don't actually. So I guess one of the reasons why modularity should be a risk is because the barriers to entry get lowered substantially. So that if you have a modular ecosystem of blockchains where it's very easy to transfer funds between networks, for example, imagine they all use a shared data layer, and so bridging transactions are very cheap. Then one could argue that Ethereum loses a lot of its explicit value, which is in the form of liquidity moats. The reason why a lot of people transact on Ethereum is because that's where all the money is, right? So if you want to do things that require things like automated market makers or any kind of price setting mechanic, you want to go where all the value is, all the liquidity is, and that's Ethereum right now. However, why did Ethereum accrue that value in the first place? It accrued it because of the utility it offers. And I think that... Sorry, I guess I'm answering a different question, really, because I guess my answer to, my thought is basically, I don't think I care if modular blockchains are a threat to Ethereum. And I'm not sure anybody else should, because what a modular blockchain world means is that the blockchain ecosystem becomes far more competitive, that a sovereign layer 1 needs to justify its existence on its own merits. It can't just take advantage of a first mover effect, and say, well, Ethereum was first, so all the money went to Ethereum, first for smart contracts, and therefore a better platform that turns up can't compete. Well, that kind of that barrier gets eroded in a modular world because it becomes much more easier for those two sovereign networks to communicate with one another, and so that's a good thing. And so there's, I guess, yeah. So winding into that, does that mean that Ethereum is threatened? Well, maybe. It depends on whether Ethereum's governance mechanisms are robust enough that Ethereum can iterate and innovate and adapt so that it does not lose its like fundamental value proposition to developers and to users.
Mustafa, over to you.
Well, I mean, yeah, I mean, it's kind of the same question, really. Like, what kind of risks are we talking about? I think like probably the main risk that people talk about is if it reduces Ethereum's moat. I guess like I echo Zach's comments on that. Like first of all, it doesn't matter. Secondly, it's not a zero-sum game. I think even if it reduces Ethereum's moat, a modular settlement layer, which is what Ethereum would be in a modular world, would have much more value than a monolithic layer 1 because it's not a zero-sum game.
What is Aztec's point of view and stance on data availability?
On data availability, well, that's necessary. So a lot of the we're having in Web3 are largely coming from the fact that like the first like programmable blockchain that turned up, Ethereum, conflated consensus. It's the consensus layer, the execution layer, the availability layer into one network. Because back in 2015 there wasn't really any other way of doing it. It's easy to criticize with hindsight, but you have a much more it's much better for the ecosystem if those layers are separated, because you can price resources more effectively, and so like networks need distributed networks need data availability. So to give an example for Aztec, in order to do an Aztec transaction, you have knowledge of the entire Aztec chain state.
Hey Zach, there's a bunch of noise in the background.
Sorry, I'm rubbing my finger over the mic. I didn't realize. My bad. To make an private Aztec transaction, you need to possess knowledge of the entire chain state, like the present chain state, to make that transaction. So, if even like a single byte of a transaction is missing, then you basically halted the network. And so, data availability is really, really important for Aztec, more so than a public chain where you have a reordering problem and double spending problems. You just fundamentally break the chain if you lose a single byte of data in Aztec. And so we, as a network, we care very much about data availability and willing to pay highly for it. But the problem with Ethereum is that data as a resource is priced, in gas, the same way as execution is a resource, and the same way as smart contracts, like storage data is priced, and network latency is priced, and they're all priced in gas, which is just one metric. And so the resource bottleneck on Ethereum right now isn't data availability, but the effect of that is it means that data is very highly overpriced on Ethereum, and so that has a big effect, a very detrimental effect on rollups. And so splitting out the data availability layer into its own network, which is optimized around providing data availability as a resource as abundantly and as cheaply as possible, is, in my opinion, like an extremely good, necessary, and valuable move.
I want to move to the quantum gravity bridge. John, can you introduce that? John 1, can you introduce the quantum gravity bridge and explain some of the synergy with something like Aztec?
Yeah, so the quantum gravity bridge is a system. Sorry, there's some feedback again. Do you think we can mute Mustafa? There we go. Yeah, so the quantum gravity bridge is a system that acts very similarly to relays. If you're familiar with things like BTC relay or systems like, let's see, Rainbow Bridge potentially, or basically any of the sidechain bridges that exist, they're a relay to another blockchain. IBC would also be a relay to another blockchain if you're familiar with the Cosmos ecosystem. So it's essentially you're running a light client of another blockchain in the EVM. You verify block headers along with something about consensus of that chain. So in the case of a proof of work relay, it would be proof of work difficulty. And in the case of something like Tendermint, which is what Celestia uses, it would be, has the block been signed off by 2/3 of the validators at stake at that particular block height. Now, unlike other relays, the quantum gravity bridge has some special properties, namely that it does not involve relaying assets. Most relays are used to be able to move an asset from one domain to another domain. For instance, BTC relay allows you to lock up Bitcoin on the Bitcoin chain and then relay them over and get minted on the Ethereum chain and then potentially back. Right? There's also other more trusted relays that don't involve checking consensus, if you want to call them relays, things like wrap BTC or whatever, right? But it's essentially a way of moving assets around. The quantum gravity bridge doesn't do that because there's not really any other assets on Celestia other than the Celestia token, of course. And there's no execution on Celestia, so there's not particularly a need for moving these assets around. Right? There's no notion of tokens on Celestia. So essentially, the quantum gravity bridge only relays data. So the relay will attest to the fact that some data was available on the Celestia chain through a Merkle root of that data. And it can batch them together, etc. There's a variety of very interesting optimizations we've made to the gravity bridge relay code, which is what this is based off of, to make it much cheaper to relay attestations. And essentially what you get on the Ethereum side is the smart contract that says, okay, this Merkle root is attested to by the Celestia validator set, and the data behind this Merkle root is available under an honest majority assumption of the Celestia validator set. Now you have this very compact, cheap way for downstream contracts, such as rollup contracts as they exist today. This includes things like Fuel or Aztec or Starkware, Optimism or Arbitrum or ZK Sync or anything you want that currently use Ethereum for data availability or that use a data availability committee to essentially drop and replace that logic with the attestations that are relayed from the quantum gravity bridge. They just drop and replace it, and they call a single function that says, does this Merkle root have an attestation on it? Returns true if it does, returns false if it doesn't. And then under an honest majority assumption of the Celestia validator set, that data is guaranteed to be available. This has nice properties over a vanilla data availability committee, and it also has nice properties over using Ethereum itself as it currently exists for data. With respect to a data availability committee, the quantum gravity bridge gives you properties that, one, as a user, you can verify that the data is available or unavailable very cheaply due to data availability sampling. You can't do this currently with data availability committees. You basically just have to trust them, and if the bridge is broken, if they lie, you don't actually have any way of knowing that the bridge is broken, which is it's pretty bad that you don't even the fact that you don't know that the system is broken is a pretty bad property to have, right? At least with data availability sampling, you can cheaply verify that the system is functioning correctly up until before you start using it. Also, the fact that this is a blockchain validator set that is attesting to data, as opposed to 7 large corporations that are just signing something, means that the users of that blockchain, in this case Celestia, can penalize those validators if they do something malicious. So if they try to relay an invalid attestation, that 2/3 of the validator set that relay the invalid attestation will get slashed. You cannot slash a data availability committee that attests to the fact that some data is available when it's not, all you can do is kind of shame them on Twitter. That's not exactly a very large deterrent. There's absolutely no financial disincentive for them to lie. While if the Celestia validator set lies, they can get slashed. And that could potentially be a very, very large penalty. This also has now moving on to the second facet, which is, what are its advantages compared to using Ethereum as it currently exists for data. I mean, we've talked about this quite a bit already in the spaces, which is that Ethereum as it exists today is a monolithic chain. If you want to use Ethereum today for data, you need to compete with arbitrage bots and MAV and NFT drops, the NFT drops that took down Solana. So it's whatever, they had 6 million transactions per second or something. So that's what you have to compete with if you want to just use Ethereum for data availability. Because Ethereum is a monolithic chain. This may change in the future for Ethereum, but currently today it is a monolithic chain, and therefore it is very expensive to use it for data availability. If you use the quantum gravity bridge for data availability, then at least initially, and for the same throughput that Ethereum currently supports, this will be substantially cheaper, as in fees will be negligible, effectively free. Obviously, if Celestia is used very, very substantially, then there's nothing we can do to avoid a fee market happening. But at least for the same usage, fees will be negligible in this configuration.
Aztec guys, do you see any concerns with the quantum gravity bridge? And do you have any questions for Mustafa and John in terms of making this practical?
Yeah, I think our stance today as a protocol is to rely on Ethereum because something like Celestia has not gone through a long Lindy effect period of being trusted. But to just underscore the problem, if you take we are releasing a product called Aztec Connect. It's a private bridge to Ethereum and allows you to do any DeFi transaction privately. And it relies on layer 1 for execution. And so if you kind of break down the gas costs of a typical Aztec Connect transaction, you'll see that there's 10K gas for the L1 execution portion, assuming there's a Uniswap swap and you're splitting that with a bunch of users. And so there's like a dramatic reduction in cost based on the size of the batch. We also have the viewing keys because we are a private rollup. And so that's another 8K of gas. And then in order to actually prove the validity of the transaction, the share of the transaction is maybe 600 gas. And then the remainder is about 8K of call data. And so I know that was a lot of numbers I just threw at you, but roughly the call data proportion of the total transaction is about 60% today. So that tells you that it's already the majority of our expenses is Ethereum L1 call data. Now, in the future, we're going to have off-chain execution. We're going to have off-chain viewing keys. And as a result, the vast majority of our costs are going to be L1 call data, up to 93%. And so, it really just underscores the need to have much, much cheaper data availability. And I think it's something that we've considered as well as this kind of what other companies call the volition approach, where users can kind of choose where their data might be stored. But I can turn it over to Zach for maybe more of the party line.
Yeah, Zach, over to you. What are your thoughts on the quantum gravity bridge and its impact on the ecosystem in the time ahead?
I think I'm just gonna to echo John there. If it's the reason why we use Ethereum is because as a data availability layer is because a bespoke data availability layer has not yet been kind of battle tested and proven. Once it is, then it's going to be a complete game changer because the monolithic chains won't really be able to compete when it comes to pricing data effectively. And it's going to open up an enormous amount of new kinds of use cases for blockchains that just currently can't priced out at the moment. I mean, it's also going to create this much more modular world where it's going to be much easier to kind of transition to transfer funds between different networks. because the overall, like the aggregate cost of a transaction is going to be extremely small once you use a rollup for your execution, and then you use something like Celestia and the quantum gravity bridge for data. Then you can use something like a network like Ethereum just for raw consensus, and the price of that can be extremely competitive when you're using a rollup. And so I think it's going to create a very different kind of landscape to the one that we have at the moment, where basically I think that the L1 wars, so to speak, are going to kind of if Celestia fulfills its vision, is going to not really be a thing anymore, because there's going to be so little to differentiate them all, that the fundamental value proposition of a different monolithic L1 is going to be seen as extremely marginal, and so yeah, I mean, I think it's going to we're going to see a much more kind of diverse world where a very large number of L1s are used in tandem with one another.
We do want to take questions here. Oh, go ahead.
Sorry to interrupt. I'm very sorry about this. I'm going to have to actually jump off now because I'm sorry. I have a hard stop. I've got some medical related things I need to deal with now. So I've got to jump off now. But it's been a lot of fun. Thank you for inviting me.
Thanks, Zach. Thanks for attending.
Cool. Cheers, everyone. Bye-bye.
Thanks a lot, Zach.
So we do want to take questions from the audience. So please raise your hand, and you can ask Mustafa, John, and John too any questions. Mustafa, over to you. When it comes to the quantum gravity bridge and that synergy with Aztec, is there anything else that you want to add to what John said, or that you think is important for us to know as it comes into practice?
So I think like the main challenge with the content with like ZK rollups using the quantum gravity bridge right now is that Celestia uses SHA-256 as the hash function for the Merkle tree, which is not ZK friendly. And so like there's different approaches like we're trying to kind of take there to solve that. The first of which is like we want to try to avoid having multiple hash functions or change the hash function, because that adds a bunch of complexity to the system. So like one approach we're trying to take is like we might have a ZK proving service that like proves that the Celestia Merkle tree or the Merkle root matches some ZK friendly version of the Merkle root. Like it could be like a Peterson or Poseidon, a hash function Merkle root. And so like ZK rollups would not have to do expensive SHA-256 operations and could just use a ZK-friendly hash function.
Got it. Any questions from the audience? Who would like to ask a question? Looking at the framework guys, a priori, Yaz just entered, Ruby. Okay, looks like we have a question here. Christian, go ahead. Ask your question. Yes.
So I had a question for the Aztec guys. So let's say there's a project launching on Optimus and Arbitrum, whatever, name your rollup. Could you run sort of an Aztec batch through that type of project, or would the project need to be on Ethereum layer 1 as well? Like
For now, we only have plans to deploy our Aztec Connect product to Ethereum layer 1. What it is it's essentially a smart contract on layer 1 that allows users of Aztec to use the rollup contract as a proxy. And so you can direct funds on layer 1 and it'll say, Aztec rollup deposited 30 ETH into Uniswap and got 100,000 DAI back, something like that. We can absolutely deploy to other L2s, and this is something we've definitely talked about internally of creating, implementing Aztec as a private L3. We don't currently have plans to do so, and part of the reason is because we still think the vast majority of the activity is on L1, and we have a bunch of cost improvements already in place due to batching. So we think it's a very compelling product to have privacy and scale directly on top of layer 1 liquidity. And the second reason is in the medium term, we'll be moving to off-chain execution regardless. And so that means having private smart contracts within our own ecosystem.
Okay, perfect. Thanks. I have a second question, if that's okay.
Of course.
What are your concerns about Aztec sort of becoming a tax haven? Because as I see it, you have a sort of CK, so you actually have the possibility, if there are enough sort of transactions in a batch, to make it cheaper to make a transaction through Aztec than on Ethereum layer 1. And so you could say that, oh, you might both sort of save the gas, but you also are less prone to sort of have the authorities checking your stuff because, well, they can't really.
Yeah, I think this is a question for any privacy protocol. Now, to date, I think the data would show that we don't have that issue, and we have a lot of internal debate as to why. Quite frankly, we don't want to be associated with illicit activity, but our stance on audit and reporting to authorities is that it's up to the individual user. And our principle as a protocol is to provide ironclad privacy and then allow the user, if they want to attest to their transaction history. And so I think that is speaking to a larger philosophical question about privacy. As a society, do we think that there's more utility in having privacy and discretion when there's undeniably some amount of potential wrongdoing that can go through the same protocol? Our goal is to just make sure that users who obviously we all encourage to abide by laws and regulations can do so. And to date, I would say that has not been a concern of ours whatsoever. Our user set is predominantly kind of small quantity users, largely largely what we would consider to be real users, and not adversarial, black hat type users.
We'll be fielding more questions. I see more folks coming in here. Jonathan, Lucian. The next question will be from A Priori. Go for it.
Hey, thank you for having me on. Question I wanted to ask about sovereignty. In terms of a settlement rollup, do you foresee the possibility that you would have other settlement rollups on top of a settlement rollup in order to, like, let's say if you had multiple municipalities that wanted to share a settlement rollup that then settled on a rollup shared with some other sovereignty in order to not sacrifice on interoperability?
I mean, that's basically like fractal scaling, right? Or like L3s, do you mean?
Exactly.
Yeah, I mean, I think L3s and fractal scaling is a very interesting idea. I know like Starkware is looking into it, and there's various other proposals. The main kind of challenge with that is how you do cross-chain communication between the different rollups in the tree. That, like, naively, you would have to do multiple transactions to like move assets up to the root rollup and then back down. But there's various proposals to try to avoid that. There's a proposal called Slush, which tries to have like transactions directly between different rollups in the tree, which is very interesting.
All right, guys. Well, I think that was it. I think that was like a good hour. I know we're pressed for time on the Aztec side. If there are no other thoughts, we can conclude here. And this was fun. John, thank you for joining.
Appreciate the time, guys. Enjoyed the chat.
Mustafa, John, appreciate it as well.
Thanks. All
Thanks,
good.
y'all.